So now let's look at 5.2 here. The question says simplify. So what does it mean by simplify? It means you're trying to reduce this expression then until it's become one number or one ratio. That is what we're going to do. Then how we're going to do that, we're going to apply the reduction formulas. Remember, then the reduction formulas in quadrant 1, then all of them are positive. And then in quadrant 2 is only sine that is positive. In quadrant 3 is only tan that is positive. Cos that is only positive on quadrant 4. But another thing that is important here, it's the expression of this quadrant. Here it's 180 plus, this is 360 minus theta. This is going to be 180 minus theta. I'm leaving out 90 and 270 because a special quadrant of cofunctions. So I'm leaving them out here. So let's look at how do you approach this. So now if I've got sine 210, then I want to rewrite this in terms of the special angles. Then obviously I'm going to be using the quadrants 180 and 360. Then if I'm forced to, then I'll be using 90 and 270. But the most preferable one is start with 180. So now how can we rewrite sine 210 using the special angles and the quadrant? This can be 180 then plus what? Plus 30 degrees. Then I got cos 510. These are angles above 360. This will be 360 degrees. Then plus 150. Then I'll have cos 315. This will be 360 degrees minus 45 degrees. Then times, remember this is times here, the negative angle of sine will be negative sine 135. So I'll start by doing that first. Then when I'm simplifying this is going to be the third quadrant. Sine it's negative. This is going to give me negative sine 30 degrees. As you can see here, I'm putting the bracket to say I'm multiplying this. This is going to be cos 150, but remember cos 150, I still have to simplify this into a special angles. So because it's 360 plus, all of the 360 plus are in the first quadrant are positive. So this will be positive cos, but 150 now I'm going to break it into 180 minus 30. This is going to be 180 minus 30. That's going to still give me 150 I mean. Then cos 45 is 360 minus the fourth quadrant. Cos is positive on that quadrant. Then times negative here, remember, then I'm putting the dot here, it's negative. Sine 135, it's the same thing as what? As 180 minus, it's 180 minus 45. So this is going to be 180 minus 45. So we can simplify this into negative sine 30 degrees again. Then I'm putting the bracket. This is going to be 180 minus, it's in the second quadrant. What is the sign of this one? Will be negative. So it will be negative cos 30 degrees. Then I'm putting the bracket over here. This is going to be cos 45. Then I'm putting the bracket. Then negative sine 180 minus, it's in the second quadrant. Sine is positive. So that means it's going to be this negative that was there. Sine 45 degrees. Then now when I'm having that special angles like that, Then now I can substitute the values of the special angles like that one, because now it's going to be easy. Then I substitute these values here. This is going to be negative 1/2. Then cos 30, it's negative √3/2. Then cos 45, then it's √2/2. Then sine 45, it's negative √2/2. So this is going to be what I'm going to have here. Then obviously from what I'm going to have here, then I can simplify this further into what? Into negative. My final answer will be negative √3 then over 2. So that would be my final answer, that one. All right, so how do you get that? This is going to be √2 times √2, that's going to be 2. 2 times 2, that's going to be 4. So it means this is going to be 2/4. That this will be negative 1/2. So I can see here negative 1/2 and negative 1/2 will be cancelled out. Then I will be left with √3/2. So that's how I'm going to get the final answer for that one. All right. Then now let's look at question 5.3. Then how 5.3 we can do that. So 5.3 is an identity proving. We are proving the identity there. So then for 5.3 we are proving this identity. So if it says is cos theta minus cos 2 theta plus 2, then equal to 3 sine theta minus sine 2 theta. So we're going to take the left hand side here, because that is what you're going to prove. We're going to see whether it's going to be equal to the right hand side. Okay, so when we are proving the identity, how do we approach this one? First thing first, we have to look at our final product. Our final answer is got the sine with a single angle. It's got a cos with a single angle. So that is our starting point. So it means our starting point now is to check in our expression, do we have any double angles that are there? If yes, we have to break them, because in our final answer we don't have a double angle. So it means we have to start by focusing on the double angles that are there. But now again, so now I'm breaking down cos. Remember, cos is got 3 possible cos 2 theta, it's 3 possible identity for it. So which one I'm going to choose for? Then I'm looking at my answer in my numerator. It's got cos. So it means I must take the answer that it's got only cos without sine. So what I mean by that, remember cos 2 theta is the same thing as cos square theta minus sine square theta, then 2 cos square theta minus 1, then is also the same as 1 minus 2 sine squared theta. So now I have to choose between these 3 identities, which one I will substitute instead of this. I'm saying to you, you look at your final answer, it's got only cos here, there is no sine. So it means I can't take this one because it's got sine. I can't take this one because it's also got sine. So that is how I determine the idea of which one I will choose for whenever I'm working on that problem there. All right, so it means now here I'm just going to substitute this one of 2 cos squared theta minus 1 all over, then this will be 3 sine theta minus, remember this one is only one option, it's going to be 2 sine theta cos theta. That is going to be that. Then if we simplify this, this is going to be cos theta minus, it's going to be minus 2 cos squared theta plus 3. That is plus 1. I don't know why I'm taking 3 here. So this is going to be plus 1. So this is going to be plus 1, then all over this one. Oh, okay, so now I see I did a mistake here. There is plus 2 that was there, so there was plus 2 that was here. Remember that? So it means here this is going to be plus 1, then plus 2. That's why I'm going to have plus 3 here. Yes. So this is going to be 3 sine theta minus 2 sine theta cos theta. So this is what I will have here. So now I'll have something look like that. So now how can I do that? So I can try to rearrange this so that I can see what I'm having here. Then I'll have 3 plus cos theta minus 2 cos squared theta all over what? All over 3 sine theta minus 2 sine theta cos theta. Alright, so what is a principle whenever you're simplifying? Each and every step you get into, you have to check if it's possible to find a common factor or if it's possible to factorize so that you can minimize that expression that is there. So now let's look at that. We can factorize this expression. The numerator, we can factorize it into what? Into this one. This will be 3. Then will be 3. Then minus 2 cos theta. Then into 1 plus cos theta into 1 plus cos theta, like that. And then let's look at the bottom. What are we having here? We notice there is a common factor of sine. So it means we can take the common factor of sine out. We're going to be left with 3 minus 2 cos theta. So that is what we're going to have. So now what we notice that there is a common factor that we can cancel out, like this one. We're going to be left with 1 plus cos theta all over sine theta. So this is going to be looking exactly like our right hand side. So therefore we must say that we have arrived to the proof. We'll say this is going to be equal to the right hand side. So that's how we prove that one there.